Welcome back. This video will explain section 7.4 on writing the equation of a line and 7.5 graphing linear equations. To find an equation of a line given a point, x, y, and the slope, we can substitute those values into our equation y equals mx plus b and solve for b. And use the values of b and m, right, our y-intercept and our slope, to write the equation in our form y equals mx plus b. Here's an example. We know a point, we know the slope. We want to replace this into our equation, y equals mx plus b. So we have 5 times 4 plus b. We know our y, so we know our intercept is negative 23, so now we can actually write out our full equation because we found out what b was. Here's a second example. Find the equation. We know a point, we know the slope. We know how to find the slope, so we know 2 points. So we subtract y minus y over x minus x. We solve and get our slope is 1/3. Then we know our slope, so we can replace that back into our equation here, knowing an x value of negative 2, and we can solve for b, our intercept, and replace that back into our equation of our line. Find the equation of a line for the following graph. Find the y-intercept. So looking at our graph, we want to know where does the line intercept or go through the y-axis, and that would be at 2. So b equals 2. Find the slope, rise over run. Well, you want to find 2 points and then figure out how to get from one point to the other. So I notice this line is going down. So to go from point A to point B, I'd have to go down 2 and to the right 3. So it's a negative 2 over 3. To put that all together, my y-intercept was 2, my slope is negative 2 over 3, so my equation of the line is y equals negative 2/3 x plus 2. Now, graphing linear inequalities, section 7.5, we first need to understand what an inequality is. So an inequality is a statement that describes how two numbers are related, whether they're less than, greater than, less than or equal to, or greater than or equal to. These are all different statements. To graph these, we can replace the inequality symbol by using an equality symbol and graph the line, and then the line will be solid if the inequality is greater than or equal to, or less than or equal to, and it's dashed, so we're saying not all of these numbers are included. If it's just greater than or less than, there's no underline, there's no equal to with it. After that, we can test a point 0, 0 if the inequality does not lie on the graph line in step 1. If the inequality is true, we can shade in the regions on the side of the line that includes 0, 0. If the inequality is false, we can shade the region on the side of the line that does not include 0, 0. So that's the point that we're testing, if 0, 0 does not lie on the graphed line. If the point does lie on the line, so your line goes through 0, 0, you can choose another test point and then follow that same shading either above or below. Here's an example. We're asked to graph 2x plus 5y is greater than or equal to 10. Let's graph that line. So here's our line. 2x plus 5y equals 10. Then look for a test point. Is 0, 0 a solution? No, it's not. So we can replace x and y with 0 and see if 0 plus 0 is greater than 10. and that would be false. 0, 0 is not included in the solution. So what is included in the solution? It would have to be everything above the line. Since 0, 0 is not included, the shaded region should not be below the line because 0, 0 is not included and 0, 0 is below the line. So the solid line indicates the line is part of the solution, and then we have to figure out what else is part of the solution. It'd be everything above our line here. Let's try another one. Graph y is less than negative 3x plus 9. So first we want to graph our line. Now identify 0, 0. It is not on the line. This line does not go through the point 0, 0. So we can check it out and say, what if y equals 0? What if x equals 0? Negative 3 times 0 would be 0 plus 9. 0 is less than 9. That is a true statement. So 0 is a solution for this equation. The dashed line indicates that the line is not part of the solution, but all of the numbers below it are. And why is it dashed? Because this inequality did not have an equal sign. It only had a less than. So if it's less than, we use a dashed line to graph. Our last example here, graph x is greater than 2. So if it is graphing it, remember we want to pretend that that greater than sign is an equal sign just to graph it. X equals 2 would mean we're graphing at the x equals 2. It would be a vertical line. It is dashed because we don't have an equals underneath our greater than symbol here. And now we want to figure out 0, 0 if the shaded region would go to the left of the line or to the right of the line. So let's start with our point 0, 0 because it just makes it easier to check with all zeros. And if I replace x with a 0 and read the statement and determine whether it's true or false, that will help me make that decision. So x, 0, is greater than 2. 0 is not greater than 2. That statement is false. So my shaded region does not go to the left. My shaded region of values that would work and be true for this statement would be all to the right, which makes sense because 3 is greater than 2, 4 is greater than 2, 4.5 is greater than 2, so all of these numbers for x are greater than 2, not the ones to the left.